All right, today we're going to be working on rational equations. So we're going to do 3 over x plus 2 over 5 is equal to x over 10. All right, whenever you begin working these problems, you know in order to add fractions, you must have a common denominator. And I don't really care how you end up getting where you're working this. Either you can get a common denominator or you can multiply through by a common denominator. When I look at this problem, the common denominator would be 10x. So this is going to need a 10 over 10. This needs a 2x and 2x, and this needs an x and an x. So if I simplify this problem out, I would get 30 over 10x plus 4x over 10x is equal to x squared over 10x. Now the denominators are the same, so you can either say, well, then the numerators have to be the same when I add them up, or I could clear the fraction out and multiply both sides by 10x. If I did that, that would give me 30 distributing through everywhere. So 30 plus 4x is equal to x squared. Okay, this is quadratic. So I know that it has to equal 0. So I get 0 equals x squared minus 4x minus 30. All right, well, we know that there are lots of ways I could solve a quadratic. One of them we just factor. So if I look at this, there's nothing that multiplies to 30 and adds to 40. So that means that this time we're probably going to need to use the quadratic formula. Okay, so in the quadratic, so it would be x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So 4 plus or minus the square root of 16 plus 120 over 2. So 4 plus or minus the square root of 136 divided by 2. I know that 4 can divide into that. So if I took that and I said 136 divided by 4 would give me 34, that would become 4 plus or minus 2 root 34 over 2, which would simplify to x equals 2 plus or minus root 34. And that would be the answer that you're looking for. So not everything is going to come out all nice and neat when we work the problems. All right, as you are working through this one, still going to be the same thing. You would begin, if I have 4 over x plus 3 plus x over x plus 1 equals negative 2 over x squared plus 4x plus 3. So the first thing I need to do is I need to factor this one. Watch for my domain restrictions. Where were your asymptotes? So x cannot equal negative 3 or negative 1. So the first part of this needs an x plus 1. This needs an x plus 3. And this doesn't need any part of it. So 4 times x plus 1 plus x times x plus 3 is equal to negative 2. So 4x squared plus 4, oops, sorry about that. That would not be an x squared. So 4x plus 4 plus x squared plus 3x is equal to negative 2. Combining your like terms together, x squared plus 7x plus 4 equals negative 2. x squared plus 7x plus 6 equals 0. This time it factors. Set each part equal to 0. And you get x is equal to -6 and x is equal to -1. However, -1 is a restriction, so that's an extraneous answer, and you would have x is equal to -6. Sorry about that. Skipped over what I needed for it to do. All right, by the same token, this would be multiplying. This is x times x minus 1. So this needs an x minus 1 in the top and in the bottom. And this needs an x in the top and bottom, and this doesn't need anything. So x plus 2 times x minus 1 minus 4x is equal to -2. Foiling or distributing that out, x squared plus x minus 2 minus 4x equals -2. X squared minus 3x is equal to 0. Factor that out. And I get x is equal to 0, x minus 3 equals 0, so x is equal to 3 and 0. So I would have two answers, but wait, we forgot to do the domain restriction. So what is the domain restriction? X cannot equal 0 or 1. There's 0, that's extraneous, so my only answer is x is equal to 3. Now, when you work these problems, you can always have some word problems that go along with that. And we have two different types of word problems. A work problem or a distance, rate, and time problem. And again, you may have set your problems up differently whenever you're doing things, so I don't really care how you work through the problem. But generally, the pattern for a work problem is together over the first person's time, and it's going to be plus there, but plus or minus together over the second person's time equals one job done. Plus or minus, because if it's working, if they're going toward the same goal, then you're going to add them. If they're going toward opposite goals, then you will subtract them. Distance, rate, and time problems, you just know distance equals rate times time. The thing you need to think about here is upstream and downstream. If something is going upstream, that is slower. So it's the speed of the boat minus the current. Downstream is faster. So it is going to be the speed of the boat in still water plus the current. So let's say Charles can paint a room twice as fast as Darwin. Together, it takes 16 hours. How long will it take if Darwin is working alone? Write the first person's time, together over the first person plus together over the second person equals one job complete. Now you have to be really careful about this because speed is an inverse thing. The faster you are, the lower your number is. So when you're doing this one, X is going to equal Charles. And 2X is going to equal Darwin. I know it takes together 16 hours. So 16 over Charles plus 16 over Darwin is equal to 1. I can make this nice and easy and go, well, 16 over X plus 8 over X is equal to 1, because I can reduce the fraction out. The denominators are the same, so I can add them. 24 over X equals 1, so X is equal to 24. So Charles is going to take 24 hours. 2x is going to be 48 hours is how long it's going to take Darwin. So be careful with it if it says something about twice as long. Okay, the last example that I have, a barge travels 36 miles upriver to make a delivery. And if he's going to go upriver, he's going to bring it back the same 36 miles. So the trip up and back takes 9 hours. If the current is 3 miles per hour, how fast was the boat in still water? Now, your two choices for working with this would be you would have either the times are going to be the same, or you're going to have upstream plus downstream equals the total time. And that's the one you have for this one. Generally, when I'm working this problem, I'm going to set up a table that will help me kind of organize my thoughts in doing the work that goes along with this. So I would set up a table where your variables are going to go across the top. So distance, rate, time, upstream, downstream. So what do I know? I know it's 36 miles upstream and 36 miles back. I know that the speed of the boat upstream is the boat minus 3, and downstream is going to be the boat plus 3. Now, thinking about the chart that you guys did when you were in biology, if I'm looking for time, time is distance divided by rate. So 36 over x minus 3 and 36 over x plus 3. So I can take the trip upstream, 36 over x minus 3, plus the trip downstream, 36 over x plus 3, is equal to the total time that it takes me to make the trip. Now, once I have that, all I need to do is solve. So 36 over x plus 3 plus 36 over x minus 3 equals 9 over x squared minus 9. So 36x plus 108 plus 36x minus 108 equals 9x squared minus 9, 81. Whoops. Combining like terms, 72x equals 9x squared minus 81. Get things equal to 0. So 9x squared minus 72x minus 81. All right, once I do that, now I can factor it out. So when you factor this, so I can take out a 9. So 9 times x squared minus 8x minus 9 equals 0. So x minus 9 times x plus 1. And I can do 9 equals 0, x minus 9 equals 0, x plus 1 equals 0. 9 does not equal 0. X equals 9, x equals negative 1. Well, it's not possible for a boat to go negative miles per hour. So therefore, that's not a possibility. So in still water, the boat would be going 9 miles per hour. And that would be what our final answer is. I hope that was helpful. You guys have a worksheet that you need to work on now.